Hello, this video is to help you create the graphs on GeoGebra for the applied linear functions exercise. So here's the applied linear functions exercise, and you're asked to draw a graph of a tomato plant. So we'll go to GeoGebra Classic, open up a GeoGebra Classic, and the first thing we have to do is match the axes, the x-axis and the y-axis, to what we see on the screen and to label them. So first, let's label them. I'm going to two-finger tap or right-click on the graphics screen to pull up this menu. We'll go to Graphics, and there we see X-axis and Y-axis over on the right. And so X-axis can find Label, and I'm going to label this Days because this is the number of days. I'm going to say Days, D bracket, and I'll see that show up on the axis. And on the vertical axis, I'm going to call that Height, because it's the height in centimeters of the tomato plant, and so I should see that on the y-axis up there. The next thing I'm going to do is drag the axis so that both axes show the right numbers. So let's just check what they should show. So I see the height should go up to say 35, and then the days should go up to 9 or thereabouts. So on GeoGebra, I'm going to take this 4-arrow tool, and when you click on this one, it's for moving the graphics view, but it's also when you hover over the axes, you can click one or the other axis and drag up or down. So this one needs to go up to 30. 35 I said, so I'll make that go up to 35, and the horizontal one only needs to show up to 9. So I'll stretch that out, to 9, like that. Now I need to enter in the function. I'm going to do that using function notation. And so by this time you've figured out that the graph is h of the h is the height's a function of days, so I'll say h bracket d equals 6n plus 3 because 6d plus 3 because I believe it starts off at 3 centimeters and grows 6 centimeters per day. Let me just check I got that right. It starts at 6 and grows by 3 centimeters per day. Got that the wrong way around. And so it should be 3 times the days plus 6. Okay, so our graph looks like this. I've got the function drawn, and it would be nice to see the name of the function on the graph. So I'm going to right-click on the line itself and go to Settings and say Value. It says Show Label. I'm going to say Name and Value, and then we see down here the name of the function showing up. And if possible, I want to have it sitting so it's not crossing the line anywhere. Okay, the last thing I need to do is put a point on the function. So I'm going to say point on object. I'm going to drop a point there, and then I'm going to be able to interpret it. And so when I right click settings there, I'm going to say name and value. And that shows me that at 4 days, after 4 days, the tomato plant should be 18 centimeters tall. So now I'm ready to take a picture and put it onto the Google Doc. I can do it in one of two ways. I can take a screenshot from the Chromebook in this way, or more preferably, not like that. I would make sure that you can see the label on the axis. Preferably, I go to File and Export Image, and copy that to clipboard. And on your Google Doc, make sure you've got a title. Control V to see your graph. Keep it big, don't shrink it down. The graph is a picture, want to see all the detail, and write an interpretive sentence about it. So this graph shows that the tomato plant shows how the tomato plant grows. At 4 days, we expect the tomato plant to be 18 centimeters tall. Okay, there's an interpretive comment about that graph. So we need to do prepare each graph with the labels and with the function and with a point on the function and an interpretative sentence. Right, thank you.